All right, best for last. For sure, this is probably the hardest problem of the page, conceptually wise. It's a little bit less intuitive, I think, from where to begin. So find all solutions sine x minus cosine of x is equal to 1 between 0 and 2 pi, including 0, not including 2 pi. All right, so they're just like your standalone sine cosine. There's like, we can't change it into anything. There's like, if you're looking at this and like what you're thinking, like what could you possibly do, you're thinking correctly. So what we are going to do is we're going to get sine of x on one side, and I'm going to add cosine of x to the other. Sine of x is equal to 1 plus cosine of x. That way each trig function is on the same side. Now, the next thing I'm going to do, because we don't have a lot of we don't have like any identities that relate sine of x and cosine of x. They don't exist, right? So what I'm going to do is I'm going to square both sides. And I'm going to put an asterisk right there, and you'll explain why in a second. So I'm going to square sine squared of x, and I'm going to square 1 plus cosine of x. I'm putting it in parentheses so that I know that I've got to four-letter F word in math FOIL 1 plus cosine of x and not just distribute that squared through. So I'm going to go sine squared x is equal to 1 plus cosine x times 1 plus cosine x. All right, so I'm just going to kind of work this right side here. So I'm going to get 1 plus 2 cosine x plus cosine squared of x. All right, so this looks great. And actually, if you're looking at this and you're like, all right, but I still have two different trig functions, you're correct. But we have a sine squared, and you have a cosine squared, and you have like a regular cosine. So here's another like piece of advice, and this piece of advice actually can go through all of these problems, is that make all the trig functions what the non-squared one is. Make all the trig functions what the non-squared one is. So if you're ever not sure, you're confused, you're like, oh my god, which one to make it, look at which trig function isn't squared. In this case, cosine. So that means I'm going to change everything to cosines. So cosine squared, that one's good. And I'm going to change sine squared using my formula from up top here, sine squared plus cosine squared. I'm going to change sine squared to 1 minus cosine squared. And I'm going to work this right side, just rewrite it. All right. All right, so let's bring everything over to one side, and we can solve, and we're going to set it equal to 0 and kind of make the magic happen here. So this 1 minus 1 will go to 0. I'm going to add the cosine. So this should look like when you combine everything onto the right side. You can make it on the left too, it doesn't matter. It should just look like 2 cosine x plus 2 cosine squared of x. I'd subtract the 1. The 1s would go away. I add the cosine squared, so I get 2 cosine squareds. All right, so now I have this form. Looks great. So 0 is equal to 2, and I'm going to factor out a 2. I got excited about the parentheses. I'm going to factor out a 2 cosine x. They both have 1 in common. That leaves my first term with a 1, and it leaves my second term just with a cosine. Okay, so 2 cosine x, 1 plus cosine x in the parentheses after we've factored. Don't just cancel things out. Make sure you factor it out, because we can't cancel out functions, remember. So now all that we're going to do is set this equal to 0 and solve. All right, so we have 2 cosine x is equal to 0. So just cosine x is equal to 0. We're in radians. Cosine is equal to 0 at pi over 2 and 3 pi over 2. And 1 plus cosine x is equal to 0. So cosine x is equal to -1, and that occurs at pi. Now, before we say all done, what we did here is way different than kind of what we did in other problems. We did this technique of squaring both sides, and that's why I put an asterisk here. Oh, so I want us to just be aware, and this is really when you have to watch out for it, which is why we haven't done it before. So when you square both sides, watch / check for extraneous, ran out of page, extraneous solutions. Okay, so extraneous solutions are solutions that we get as an answer, but will not work in the original equation. So extraneous solutions, they won't work in original. So because we squared both sides, we have to check our work. We are probably almost guaranteed to get at least one extraneous solution. So all that we're going to do is we're going to check these three values, pi over 2, 3 pi over 2, and pi, and see if there's 1 or 2 or all three that we can cancel out. So check. So sine pi over 2 minus cosine pi over 2, and we're saying, does that equal 1? Sine of pi over 2 is 0. I'm sorry, I've got sine of pi over 2 is 1. Cosine of pi over 2 is 0. 1 is equal to 1 minus 0 is equal to 1. Great. So sine 3 pi over 2 minus cosine 3 pi over 2 is equal to 1. We're checking, does that work? Well, cosine of 3 pi over 2 is 0 because we have that from before. And sine of 3 pi over 2 is negative 1. Negative 1 minus 0 does not equal 1. So 3 pi over 2 is out. Okay, extraneous. All right, and then last one, sine of pi minus cosine of pi. Does that equal 1? Sine of pi is 0. Cosine of pi is negative 1. 1 is equal to 1. Works out great. So different technique here than we've done in the previous problems. I think that makes this problem a little bit trickier. The actual math that we did, once we made these kind of jumps, wasn't different than anything else that we have done. It was just kind of getting there. You definitely have 1 or 2 in your homework like this, so make sure that you can do them, and then keep your notes handy as you're going through them so you understand kind of where we get all these answers from.